Welcome back to Miss Teacher Tube with Janice Leon. Today's lesson is going to be all about building a floating object out of something that doesn't float. This is plasticine, otherwise known as modeling clay. This is not a floating material. It's actually quite heavy. And if I were to take this block of it and just drop it in water, it'd head straight to the bottom. No buoyancy force at all to this. So what we're going to try to do is take this material and build a floating watercraft out of it. You are going to have an opportunity to build later, but right now I'm going to show you my sample of building two different boats with the same amount of modeling clay. So I'm going to shape this plasticine into a boat and try to make a boat that floats on water. In the next lesson, in the next video, we're going to have to put a load inside these boats and see how much they hold. I'm going to build mine first, but you'll have a chance to build yours later. We'll see you soon.
Welcome back. Before we examine my plasticine boats, let's take a look at some real-life boats and have a look at the materials they're made of. Most boats are made of wood, aluminum, steel, fiberglass, or any combination of these materials. Wood has traditionally been a material used for boat building. Steel is commonly used on larger vessels, and aluminum is usually found on canoes, pleasure crafts, and power fishing boats. Most recreational watercraft are made of fiberglass. Each material presents advantages and disadvantages. Wood, while being very beautiful to look at, is time-consuming to maintain. Wooden boats must continually be sanded, varnished, and painted. And the seams on the boat must be caulked repeatedly to prevent leaking on the boat. Also, rotting can be a real issue depending on the type of wood that's used. Steel boats are very strong and durable. Large ships like cargo ships, military vessels, and cruise ships tend to be made of steel. However, steel boats are prone to rust if the material is not properly protected. Aluminum, on the other hand, is very affordable, lightweight, and durable. Unfortunately, aluminum is also prone to corrosion. Fiberglass boats are relatively inexpensive and easy to maintain, but sometimes there are flaws in the hull of these boats and it's very difficult to see them. It seems like there are lots of things to think about when building boats. Boat builders don't just need to think about the buoyancy force of the materials they're using to build, they also need to think about the type of load the boat will be carrying and how durable the materials are. I'm glad that our little plasticine boats only need to carry a load of marbles. Well, let's see how we can plan and design our plasticine boats. I'll see you soon.
Welcome back. So today we're going to be building two plasticine boats. Now your group is going to get two pieces of plasticine and they're going to be roughly about the same size. Now your goal is to build two very different looking boats with the same amount of plasticine, so that you have to have equal amounts of plasticine and have them float on water. And there's a number of different ways you can build your boat. Some students in the past that I've worked with have rolled their plasticine into long pieces and then slowly built it up like you're building a clay bowl with a bottom in it. If you're going to do it piece by piece like that, please make sure the most important thing you do is smooth out your plasticine so there are no holes in between and everything's perfectly bonded together. If there's any holes and water gets in, remember, this already isn't a very buoyant material to build with. If I drop this in water, go right to the bottom. So the only way we can make this more buoyant is to keep the water out, because the minute water gets in, it's going to add weight to your boat and, well, it's going to decrease the buoyancy force and down it goes. So be very careful when you're building together. I'll show you what my boats look like as I build them. See you in a bit. So the technique that I've started out with is kind of pushing my thumbs into the middle of my block of plasticine and kind of pushing an inside into my big block. Now it takes a lot of strength to do that. And let me tell you, I'm a wee bit tired. But once you get working the plasticine, it gets softer and easier to push into different shapes. Now you may want to break it apart and make balls and push them together. You can do that too. Just make sure you don't go too thin, especially on the sides and the bottom, because eventually we're going to want this thing to carry a load. And all those beautiful glass marbles of mine, we're going to eventually try put as many as we can in these until they sink and see who can carry the heaviest load. So you can see my boat's coming along quite nicely. Don't worry about your hands getting a different color, it all washes off. I'm not real happy with how flat and wide this is, so I'm gonna build up my sides a little bit more, maybe roll them in like so, and push them back together just to build them a little thicker and a little higher. So I'm going to play around with this and I'll check back with you in a couple minutes. Now I did manage to get my sides a little higher by rolling them taller, but then I wasn't happy with how flat this was because it ended up looking like, I don't know, a bowl. And I don't think that's going to do really well in the water. So what I decided to do was pinch my ends closed just to give it a little more height, to make my sides a little taller, because remember, we don't want our little boats to take on any water, because water adds weight to our boat and it'll decrease the buoyancy force and they'll just end up sinking. And we want them to sit up as high as possible. If you do this design and you push your ends together like I'm doing, make sure you build this corner up. Can you see how this got a little bit lower here? I'm a little worried that that might be a weakness in my boat. So I'm going to continue to play with this and see what kind of shape I can get these sides into. And I'll check back with you in a minute. Okay, so I've managed to raise my sides a little bit more by pushing them in some more and building that plasticine up on the edges. Now it's a little deeper. I'm not real happy with how narrow the base is, but we're going to be looking at different actual real life boat models and pictures as you're building to give you some building ideas. Now I was looking at some of them and I noticed that this part, the hull, goes quite deep in the water for some of them. So this part being quite tall seems to be very important for them to float. But I also noticed that the cargo ships, which hold like an enormous amount of weight, have a very flat, wide base to them. So what I think I'm going to do is I'm going to do one boat maybe a tad narrower than the other boat. My second boat, I think I might do a much wider base and see which one of the two floats better. I think overall, I'm kind of happy with the look of this one. I think it'll float. Maybe not the greatest. I might rework the hull a little bit more on the bottom. Yeah, we'll see. So I'm going to get building my second boat while I'm thinking about this one. Might tweak this a little bit. And it's totally okay that when you're building, if you have some ideas as you go along, you can go back to your first boat and tweak it a little bit, change it a little bit. If you get some ideas along the way, okay, I'll check back with you in a few minutes. Now I'm building my second boat. So I've already started kind of flattening out my piece of plasticine. Now this one it has to look different than the first boat. And I'm kind of taking my inspiration from those great big cargo ships that we were studying. And I'm gonna make this one much, much wider at the bottom. And maybe the sides will be a little thinner, not super thin though, because we have to carry a load inside of it. But it's gonna look very different from the first boat. So far it's kind of, see how it's a lot wider. I just have to build my sides up a little bit because I just have a feeling once you feel the weight of your plasticine, it get a little bit worried that if it looks like that, it might just go to the bottom. So I'll check back with you in a couple minutes. And I'm back. So I've been working away on this. You can see it's a lot squarer than my first one. Now, I think I've come up with a technique to shape my corners so that I can get my sides a little bit taller. So what I'm going to do is I'm going to pinch them together, and they're going to look like a rectangle with weird corners when I'm done. But this will allow me to use this extra clay off the corner to actually work my sides a little taller. Now you can see how deep it is. It almost looks like a box. Yeah, well, I'm gonna keep working on these corners, and I'm gonna check back with you in a couple of minutes. Again, don't be afraid to tweak the design of the first one if you're getting ideas as you go along on the second one. I've already got an idea of what I might do to help that first one along. But again, they have to be very different looking boats. And I'm back. So I finished my second boat. Now, again, it's a lot squarer than the first one. It's kind of deep inside. It has tall sides. The hull is very flat on the bottom and wide. Remember we talking about making things wider in the water? Actually helps us take advantage of a little bit of surface tension to help the boat along. The wider it is, the more buoyancy force it gets, but it really helps the boat stay up higher in the water. I think I'm done this one. I really worked on my sides, and I went through the inside of my boat. I made sure there were no holes, and I smoothed it out the best I could. Now, while I was doing that, I had another idea for my first boat. So with the first one, I thought, you know, if I close the edges off, more like a kayak, a little canoe looking. Marbles, I'll still be able to get a load in there of my marbles underneath the corners, but this might actually keep more water out. But while I was working, I thought maybe I should stretch this out too. So pull in my corners on the top and the bottom, but keep it wide in the middle, because remember, we don't want our boats too narrow or it's going to decrease the buoyancy force on them and they're going to go very low in the water. Okay, so there's boat number one and boat number two. Both are very different. Now we'll see how they float. Okay, here's the next phase of our experiment. I'm going to take my beautiful boats and I'm going to try float them in the water and see what happens. So here we go. This is my square bottom boat where I took my inspiration from those big cargo ships. Let's see what it does. Oh, it's a floater. Here we go. I'm actually pretty impressed with how that floats. The water, however, is coming up pretty high on the sides. So I'm not sure what kind of a load this is going to be able to take, but I am pretty impressed that it's a really good floater. Okay, let's try the second boat. Now the second boat, I'm just going to float that one over there. The second boat, remember I took my inspiration from kayaks and canoes, and I've got a flatter bottom, but you know, it's definitely pointier on the front and the back. Let's see how that one does. Ooh. Oh, that's sitting very low in the water. I'm not sure if that can take on much of a load at all. I think the cargo ship style was the better one of the two. Oh, I've already taken on water and I just touched it. Let me see if I can get that to float a little higher on the water just by gently putting it in. It's not the greatest boat design. Not the greatest boat design. It still is floating, but I can't see it taking on a really good load. This one, by far, the tanker, I should say the cargo version, was by far a better boat. Okay, well, I'm gonna maybe modify these a little bit now that I know how they float before I go putting a load inside of them. So I would suggest you do the same after we test your boats. If you're not entirely happy with the design, talk to your group members and rework the design into something you're happy with. See you soon. we certainly have learned a lot building our plasticine boat models, it's taught us a lot about buoyancy force, how to make something that's, well, not buoyant, like the plasticine, actually float on water. And building the two different style models has really helped us see what things really aid us in making our boat float better in the water. Now, the next test for us is seeing what kind of a load we can get into our boats. I know I have to tweak my one model. Certainly my cargo-inspired model floated better on the water and will probably take on a load better than my canoe-inspired one. I'm going to tweak mine a little bit before I start putting a load in them. You do the same to yours. Talk to your group members and see if you can make your boat model a little bit better before we go putting a load on it and seeing how it floats carrying a load. Again, if these videos are helpful to you, please like and subscribe. I'll see you next time.